All right, next up in 4.5 day 1 is the graph, the basic graph of secant. Now if you watched the last video with sine, this is going to seem very, very similar to it. Not quite as long because I'm going to go through things a little bit faster here, but there are some subtle differences that you'll want to notice. First of all, secant is based off of cosine. It's the reciprocal of cosine. So what we're going to have here is that everywhere cosine crosses the axis, that's going to be one of our vertical asymptotes. But like before, we're going to do sort of the same process where I'm going to graph cosine first as dotted lines, and then I'm going to go and try to find out the secant graph. So I'm going to do that, noting that the period again is 2 pi, because that's the period of cosine, that's going to be the period of secant. I have it 2 pi broken down into 4 equal chunks. And now I'm going to do my important points. The cosine graph starts up here at 0, 1, and then we're going to go down and follow the pattern from there. I'm going to do the same pattern over on the other side. And so once I've got those dots, I can connect those. Remember to please use a dotted line here, because that tells us that it's not a part of the graph, but it's giving us a sketching aid to make a more accurate secant graph. All right, now that I've got that, like last time, we're going to put vertical asymptotes at the places where the cosine graph crosses the axis. And so I've got these vertical asymptotes, and again, also dotted lines. Also, I'll mention, which is very similar to the last example, that a full period is a full period of the cosine graph. So you're going to see a bunch of branches here for secant, but remember that it takes 2 branches to make 1 full period on secant. Also, like the last one, we're going to be picking a value. I want to pick the point that's halfway in between this first tick mark and the axis. That just, I believe, makes it the easiest overall process. So I'm going to pick that point. Now, also like last time, we've got these things labeled here. This is 2 pi, this is pi. Halfway between pi and 0 is pi over 2. So that's this one right here. And then halfway in between 0 and pi over 2 is pi over 4. So this little point right in here, this x value is going to be pi over 4, and I'm going to use that again to plug into secant. Like last time, I mentioned that if you choose your points the same way that I'm choosing them, then you will always somehow come back to pi over 4 in this process. All right, now that I have pi over 4, like I did last time, I'm going to plug it into my formula. Go over here with secant. Y equals secant of pi over 4. Also, like last time, I'm going to draw a triangle for this. I'm going to draw my 45, 45, 90 triangle, because that's where pi over 4 goes. So I'm going to square root of 2 over 2 for each of the legs, and then 1 for the hypotenuse. All right, now that I have that, I am going to calculate the secant. Secant is hypotenuse over adjacent. When we divide by a fraction, it is the same thing as multiplying by its reciprocal. So this means the same thing as 1 times 2 over square root of 2. When I multiply by something by 1, it's just itself. So that's the same thing as saying 2 over square root of 2. And then if I want to get rid of the square root in the denominator here, I need to multiply by square root of 2, both top and bottom, giving me 2 square root of 2 over 2. The 2's cancel, and I get square root of 2, which also, like we saw last time, is about 1.4. So when we're labeling the point on the graph, I do want you to use the square root, the exact value, but when you're plotting it, you want to know the decimal approximation so that you can make an accurate graph. All right, I'm going to, again, make an extra tick mark above and below just so we have a little bit of reference point there. So up to positive 2 down to negative 2. And then I'm going to plug this in. We're going to have, at an x value of pi over 4, it gives us 1.4. And so that is about right here. And then I'm going to mimic that value for negative pi over 4 because these are going to have symmetric branches to them. Also, as I mentioned in the last video, the point at the tip of each wave for cosine is going to be a value, because 1, the reciprocal of 1 is still 1, and I'm going to connect the dots. And I'm going to repeat the pattern for the other branches, just making sure that I have at least 2 full periods in my graph. Now, I've run out of room a little bit on this side, but I can do a half period. There's nothing wrong with that. So I'll do a half period over here. And do full one over on this side. And then a half one over here. So like that. All right, so now I've got just about everything I need. Let's just check to see that we have 2 full periods. A period is 1 up, 1 down, so I've got 1 up, 1 down, and then 2 halves that are up, so that looks good. That's a full 2 periods there. Now, if you wanted to just extend it this way instead, make it another full period. If you like doing it that way, that's fine too, just as long as you get 2 full periods in there. But then the last step, as I mentioned, kind of like in the last problem as well, is to label this one point that we found. It was pi over 4 for the x value and square root of 2 for the y value. I would like you to make sure you label that point, so I know that you got that by hand, that you're able to get all of this stuff, and that we're not just plugging it into the calculator. So that is the basic graph for secant. The final one that we'll do is going to be looking at some transformations of secant or cosecant.